Hi guys, it's Miss Griffin. We're looking at Unit 8, Skill 5. How do we solve logs or log equations? So we're not trying to build fires again, I already told you that. But what we do need to do is first isolate the log. So step 1, we'll write our steps out here. Isolate the log. So if it's not already by itself, you got to get it by itself, right? Step 2 is to change forms. So what I mean by that is that we're going to change from log form to bend form. So we have to recall last video where we had log base of n equals e. To switch forms, we can do the loop method or base stays base, switch the other two to tell us that the base is raised to the exponent equal to the number. Okay, so we're going to switch forms, and then step 3 is just to solve. So from there, you should be able to solve it. So we'll see this first example. The log is currently by itself, so that's a good thing. So now we're moving on to step 2. Base stays base, switch the other two, or use your loop method. And now x is already by itself, so guess what? Type this in your calculator, or do it in your head. That's 1 over 3 to the second. 3 to the second is 9, so x equals 1/9. Boom. Done. Right? You're like, oh my gosh, that's cake. I could do this all on my own. But you should still watch the video because it gets a little trickier. So here I've got the log. I've got this 5 in front. That 5 is currently being multiplied, so I'm going to divide it. Isolate the log. Get it by itself. So we have log base 6 of b equals -2. Then switch forms. 6 to the -2 equals b. B is by itself, so type this in your calc, or do it in your head. So b equals 1/36. All right, again, isolate the log. This -3's got to go. Log base 3 of n equals -1. Loop it. 3 to the -1 equals n. I don't know why I changed from capital to lowercase and whatever, but doesn't matter because 3 to the -1 is n equal to 1/3. And now here comes a little bit trickier stuff. This log is currently by itself. We got to use our loop method. So we have x to the -5 raised to the -3/2 equals 1 over 343. Now you're like, oh, shoot, I can't just type that in my calculator. But what you can do is get rid of this power. So remember that Rogers talked to you guys about reciprocal powers. If you want to get rid of a power, just raise it to the reciprocal. So in this case, flip that fraction. Whatever you do to one side, you got to do to the other. So these ones cancel. That's beautiful because that gives us x minus 5. On the right side, we're going to type this into our calculator. I probably wouldn't suggest trying to do that in your head. It's just going to be easier on your calculator. 1 over 343 raised to the -3/2, or 2/3, excuse me. That gives you 49, and from here you can just solve by adding 5. And we're done. Flip it over so we can see a couple more examples. So this one, we are now given the equation in bend form. So our steps here are going to be similar, but first we have to isolate not the log this time, but the exponent. We should say isolate the base with the exponent. Then secondly, we're going to change forms. And so here we're starting with Ben, and we need to get it to Benny by using the L method, or base stays base. So this would switch to log base in the basement of n equals e, the exponent. And then third, we'll just type it in our calculator. So here we've got the exponent and the base already by themselves, so that's cool. Then we're going to change forms, so I'm going to do base stays base, or the L method. So I have log base 5 of 100 equals m. Now m's by itself, so this just has to go into our calculator. So to type it into the calculator, what I'm going to do is go to this button that says 10 to the x, but I got to hit control to get the log. So control and then 10 to the x, and it looks like this. So remember that we're typing in a base of 5, so 5 is going to go in that little lower spot. I move over, and we need 100 to be typed in the parentheses. And I hit enter, so I've got 2.86135, so I'm going to write that on my paper. So I wrote down what we got, and then it says round to the nearest 10,000th. So 10,000th is 1, 2, 3, 4. Tenths, hundredths, thousandths, 10,000. So this 3 looks to the 5. So we have m equals 2.1684, final answer. All right, so example 2, very similar. Get the base by itself. So the base with the exponent has this plus 3 on the tail end, so we got to get rid of it. So now we have e to the x minus 7 equals 88. Then, because we have to change forms and it's a base of e, we're going to use the natural log. You could also use the regular log. Either way, you're going to get the same answer. So base of e of 88 equals x minus 7. So I'll show you how to type in natural log. If you use regular log, that's totally okay too. But just keep in mind that you want to type this into your calculator. Okay, so to get the natural log, I'm going to go back to the same spot. You see how there's log and then there's ln, natural log. So I'm going to hit control and then natural log. And I can see that it types that ln. They don't give me a spot for the base because the base is just e. So I'm going to type in 88 and hit enter. Now I get 4.47734, and I want to show you that if I use the regular log, base e, I would get the same thing. So I'm going to go back down, control, log. It says I need the base, so I'm going to type in the base of e. So I get that e by hitting the pi button, and it pulls up these options, so I got to move over to the e, and then again of 88. Same exact thing. So you can do this in either way. If you use the natural log, you don't have to type in the base of e. If you use the regular log, you do, and you get that e from using the pi button. So I'm going to write this down, round it to the nearest 10,000th. So I told you we were going to round, but I forgot that we still had to add this 7 to the other side. So I don't want to round until the very end. So now I know that this is going to give me 11.477, and then I know that that 3 will stay as a 3 based on the 4 that comes after it. Okay, so take your first step in getting the base to the exponent by itself here in question number 3. So I've got 16 to the n minus 6 equals 0, and then I'm going to change forms. So we've got log base 16 of 0 equals n minus 6. So type in log base 16 of 0, and your calculator will tell you that it's undefined. So I would be like adding 6 to an undefined value, so n equals the empty set, which means that there's no solution. Okay, so whenever you try to take the log of 0, remember that we can't have a log of anything besides positive numbers. Then it gives you no solution. I'm just going to move these things up, and then we're going to try number 4. So first we got to get that 0.6 or 6.3 away. So now we have negative 0.7 e to the 6x plus 2 equal to negative 89.7. We've got to get this base to the exponent by itself, so divide by negative 0.7. So we have e to the 6x plus 2 equal to 128.142857. Go ahead and change forms. Pause your video to do that. So I chose to write down the natural log this time. You could have written down I wrote down the regular log, not the natural log. You could have written down the natural log. Either one is fine. When we type this into the calculator, we get 4.85315 equals 6x plus 2. So go ahead and you should have found x equals 0.4755. If you have any questions, let us know, but this is all pretty much calculator based once you're solving the second type. The first type, you could probably do a lot of it in your head, but make sure that you practice. Again, you have to practice in order to be successful at these skills. Have a good day.